WMaster LoRaMaster LM100 and LoRa controller LC144 adopts one-to-many network topology as in this illustration. One LM100 LoRaMaster can form private LoRa network with multiple LC144 LoRa controllers to replace traditional wire connection. The uplink Modbus PLC or PC can connect LM100 through a 2-wire RS485 to USB adapter. When the host pulls the Modbus RTU device connected to LC144, the Modbus query message sent is sent to LC144 via LM100. After receiving it, LC144 sends it to the Modbus RTU device. The same Modbus response message is forwarded to the host computer via LC144 and LM100. The structure of this demo shows LM100 is connected to the PC using an RS485 to USB adapter with Modbus pole running on the PC. The Modbus pole is a free software to simulate Modbus host computer. LC144 is connected to Modbus RTU device, in this case, the ES104 weather sensor. In this Modbus topology, Modbus IDs of the three devices LM100, LC144, and sensor cannot be the same. The ID of the device are pre-configured as 1, 2, and 3. Download LoRaMAC utility from WMaster website. We will first configure the LC144. Use the micro USB cable to connect the LC144 and the PC. Open LoRaMAC utility. Select the corresponding COM port and then connect. Login by admin and admin. After the connection is successful, first configure the RS485 parameters on the serial page. The parameters here should be consistent with the sensor serial parameters. Here you can view the quick guide of the sensor. Choose the serial parameters baud rate 9600 data bit, 8 parity no stop bit 1. Write the LC144 ID as 2 in the device Modbus address. Click Write to write the parameters. OK will be displayed in the lower left corner of the utility to indicate that the writing is completed. At this time, you can click Read to view and confirm the current device parameters. Click Group Net to create a wireless communication group for LM100 and LC144 on this page. Here, LC144 will identify and send the LoRa packet to the host LM100 in the communication group, so the group owner ID should fill in the device ID of LM100 and write the value 1. You can select On or Off in AES Enable for data encryption of LoRa transmissions. After selecting On, you need to enter the key in the AES key field. Simply enter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. You need to remember this key here because you need to fill in the same key when configuring LM100 later. Set the timeout for each communication between LC and Modbus RTU in LC timeout. The default configured here is 500 milliseconds. Destination ID selects the ID of the Modbus RTU device connected to the LC144. Check Slave ID 3 here for the sensor ID and click Write to save the change. Click the LoRa page to configure LoRa transmission parameters. Select the radio frequency that is allowed to use in your region. Select bandwidth for best data rate. Choose the spreading factor according to the transmission distance. The larger SF will increase the distance, but also the latency. Select the code rate for error checking, and choose the transmission power. Here we configure 868 MHz frequency, 125 kHz bandwidth, SF7, 4, 5 code rate, and maximum 22 dBm for power. Click right to save the change. Now we finish configuration of LC144. Click Disconnect. Connect to LM100 with a micro USB cable. Select the COM port that the USB is connecting to. Click Connect and log in by the same admin. After the connection is successful, first configure the RS485 parameters on the serial page. The parameters here should be consistent with the host computer parameters. The host computer in the demo is Modbus Pol software. Click on Modbus Pol to view the serial parameters. Here we select 9608 data bit no parity and 1 stop it. Write LM100 ID as 1 in the device Modbus address. Click right to save the change. Click Group Page to define the LoRa group for LM100 and LC144. Since LM100 itself is the host, there is no need to fill in the group owner ID. The rest of the configuration should be the same as LC144, which we just finished configuration. Select On for AES Enable. The AES key is the same in LC144 as 01234567889ABCDEF. Set the timeout for each communication between LM100 and LC144 in response timeout. The default here is 5 seconds. In Destination ID, select all the device ID inside this group. In this case, we check Slave Device ID 2 for LC144 and 3 for the Modbus sensor. Click right to save the change. In LoRa page, use the same configuration as LC144 we just did before. Click right to save the change. Now we finish configuring this LM100. We can disconnect and check if the Modbus sensor can send data to LC144 and through LoRa to LM100, and then the Modbus pole on the PC that LM100 is connected to. Open Modbus pole, click Connect, and select the RS485 to USB port connected to the LM for the COM port. After the connection is successful, select the register address to read the sensor parameters. The address can be found on the quick guide of the Modbus sensor. Here we can see address 501, 502, 504, 505 can be read. We enter the slave ID 3 as the sensor ID and function code 03 for read. Enter the address 501 and quantity 10 for number of registers. Since we use the PLC address format, we need to check the PLC address. Click OK to apply the changes. Now the sensor parameters are transmitted to the host computer Modbus pole through LoRa correctly. This completes our configuration today.